So here you can see a dam which has been constructed across the river for storing water in a reservoir behind the dam, and water from this reservoir flows through the penstock inside the dam. Okay, so you can see the water flowing through the penstock inside the dam, and at the end of the penstock you can see a turbine connected, and this turbine converts the energy of the flowing water to mechanical energy. Okay, now there is a metal shaft connected from this turbine into the generator, and this generator converts the mechanical energy into electrical energy. Okay, so thus hydropower is generated, and from there we get electricity at our home through transmission lines. Okay, so from flowing water the energy is converted to mechanical energy by turbine, and then this mechanical energy is converted to electrical energy by the generator. So this is the basic of hydroelectricity generation. Okay, and it is one of the most important questions which has been many times asked in the interview. Okay, and it has been observed that students don't give much attention to this chapter of irrigation and water resource engineering during their BTech, but it's time now to give much more attention to this topic, because you are going to get a lot of questions from this topic. Okay, and for interview you cannot predict the exact questions, but if you know from where they are going to ask you, and if you prepare accordingly, then this will boost up your confidence, your interview stress will be less, and your responses will be much stronger. Okay, so let's check out some most frequently asked interview questions from this topic. So let's get started. Hello everyone, welcome back again to EduPortal, and this is part number 2 of our video course, that is interview preparation with question and answer for recruitment of assistant engineer civil in various state public service commission examinations. And as you know, in this video course we discuss the most important questions which have been frequently asked in previous years, and the other probable questions which are going to be asked in the upcoming interviews. Okay, so today's topic is dam structure and hydropower, and it is from the subject irrigation and water resource engineering. Okay, so we will discuss some important questions from this topic. Okay, so what are the things that we are going to cover in this video are, first of all, dam. Regarding the dam, what is a dam, its structure, its classification, and its purpose, etc. And then hydropower, that is how hydroelectricity is generated. Okay, so these are the things that we are going to cover in this video. Okay, so let's get into the topic. So the first question that comes is, what is a dam and what is the purpose of construction of dam? And as you know, a dam is a hydraulic structure. Okay, so there are some specific terms that you must mention whenever you are going to define something. Okay, so first of all, it's a hydraulic structure, then it is built across a river. Why it is built? To create a reservoir. Now what is the need for creating a reservoir? For impounding water, that is for storing water. And where the reservoir is situated, it is situated on the upstream side of the dam. Okay, so a dam is a hydraulic structure that is constructed across a river to create a reservoir for storing water on the upstream side of a dam. Now what is the purpose of storing this water? So the purposes are, first of all, irrigation purpose, second, hydropower generation, third, water supply, fourth, flood control, fifth, navigation, sixth, fishing. Okay, so these are the purposes for constructing a dam. It is a hydraulic structure that is constructed across a river to create a reservoir so that it can store water on the upstream side, and the purpose is to fulfill these things. Okay, irrigation, hydropower, water supply, flood control, navigation, fishing. Okay, so these are the purpose of construction of dam. Okay, now this is a section of a dam. Now you must know the some terminologies. Okay, first of all, crest. What is crest? It is the top portion of the dam, and it is used as walkway or roadway over the dam. Okay, so this is the crest, that is the top portion of the dam. And the then comes heel. What is heel? Now this is upstream side. Okay, upstream side, and this is downstream. This is downstream side. Okay, now heel is the portion of the dam which is in contact with the ground on the upstream side. Okay, similarly, toe is the portion of the dam which is in contact with the ground on the downstream side. Okay, so these are 2 points: top, heel, and toe. Okay, now there is a freeboard. Freeboard is the difference between maximum water level and normal water level of the reservoir. Okay, so this is freeboard. This is maximum water level. This is normal water level. Now, sluice way. What is sluice way? Its purpose is silt removal. Silt removal. Okay, so it's an opening near the base of the dam to remove the silt that is accumulated in the reservoir. Okay, so this is sluice way. Now gallery, it is a long and narrow opening through the dam. Okay, and used for the purpose of inspection gallery, that is called, or used for the purpose of drainage, that is called drainage gallery. Okay, so it's a long narrow pathway through the dam used for inspection or drainage. Okay, and then there is a spillway. Okay, so spillway, it is through the spillway or above the spillway the flood water is discharged. Okay, flood water is discharged through the spillway or above the spillway. Okay, so these are the most important terminologies regarding the dam that you must know. Okay. Okay, now let's come to the classification of dam. Okay, so different types of dams are there. Okay, and now first of all, dams are classified based on function. Okay, based on the function of the dam, it can be classified into three categories. One is storage dam, second is diversion dam, third is detention dam. Okay, now this storage dam can be classified into four types: gravity dam, earthen dam, rockfill dam, and arch dam. Now what is the purpose of this storage dam? Its main purpose is to store water when the river flow is high. When the river flow is high, especially in the rainy season. Okay, and storing this water and then using this stored water for irrigation purpose or water supply purpose or hydropower generation purpose. Okay, so this is storage dam. And next is diversion dam, and it can be classified into two types: weir and barrage. Okay, and its function is to divert the main flow of the river. Okay, divert the main course of the river into a canal. Okay, so this is diversion dam, and it can be of two types: weir and barrage. Okay, and then comes detention dam. It can be of two types: dike and debris dam, and its function is to control flood. Okay, so based on the function, dam can be classified into three categories. One is storage dam, then diversion dam, and then detention dam. And each type of dam have different other classification, like gravity dam, earthen dam, rockfill dam, arch dam, and here weir, barrage, and dike and debris dam. Okay, I am not going in detail of every type of dam. That we will do in our other course. Okay, let's move to the next classification, that is classification. This is based on construction material used. Okay, so based on the material used for the construction of the dam, it can be of two types. So these are called rigid rigid dam, because these kinds of dams are constructed by using rigid materials like masonry, concrete, timber, steel, etc. So according to the material used, the dams are named as masonry dam, concrete dam, timber dam, steel dam. Okay, and then these are called rigid dam and non-rigid, and these are called non-rigid dams. Non-rigid dams, and these are earthen dam, rockfill dam. Okay, I will talk in detail about earthen dam in our later videos. Okay, so this is the classification based on the material used. Now this is another classification. This is based on the design. Based on design, dams can be classified into spillway, buttress dam, and embankment dam. Okay, so we have seen the classification of dam based on three different things. One is function, next is the material used for construction, and third is design. Okay, this is the general classification of dam. Okay. Okay, now in the figure you can see a dam. Not only the dam, you can see the overall site of the dam. Okay, now suppose you are to select a site where you want to construct the dam. Okay, now the question comes, what are the factors that you should consider when you are going to select the site? Okay, now we will see what are those important factors that we should consider when we are going to select a site for construction of dam. Okay, so let's see. So first of all, the topography. Okay, so first comes the topography, and here for storage dam, for storage in the upstream side, the slope should be gentle. The slope should be gentle and channel should be wide channel. Okay, so this is in the on the upstream side, favorable topography. Now in the downstream side, for hydropower generation, on the downstream side, the slope should be steep. Okay, and channel should be narrow. So these are the favorable topography for dam. Okay, and one more thing you can consider is that the dam should be located on the high ground. Why? Because this will help in drainage. Okay, so this is topography. Okay, now the foundation condition, it should be favorable, and the favorable foundation condition is hard rock. Okay, so hard rock. But if the foundation condition is not favorable, then it will increase the cost of construction. Okay, uh, so that the foundation condition become favorable. Okay, and then the material availability, should be easily available. Otherwise the transportation cost will be high. Okay, but if it is easily available, then transportation cost will be very low. But if not, then transportation cost will be high. Okay, then site for spillway. Now function of the spillway is to discharge the surplus water. Okay, and so there should be a suitable site where it can discharge the surplus water. Okay, and earthquake zone, it should not be located in no earthquake zone. Okay, uh, no earthquake zone. Okay, so it should be located in such an area where no tectonic activities are generally happens. Okay, so these are some favorable conditions. We will see some more conditions like more factors like labor availability. Same, so labor should be easily available. Why? Because if the labors are easily available, then the work progress will be high, and there will be no delay, and total project cost will be less. Project cost will be less. Okay, so labor should be easily available, Then dam location and accessibility, it should be easily accessible, and the dam and the location should be such that it is connected with town. It is well connected with town or the city. Okay, and then existing infrastructure, okay, it should be present there. Okay, if existing infrastructures are present, then the project cost will be less. Project cost will be less. Okay, and then it risk to local population, and it should be located in such an area where population where the area should not be highly populated. Okay, because if the area is highly populated, then, and if suppose there is a disaster, okay, in case of disaster, and there will be risk of life loss. Okay, so it should be located in such an area where there is a less chance of loss of life in case of disaster. Okay, and the environmental concern, it is very important, and it should be located in such an area such that it doesn't disturb the local ecosystem system, plants and animals and endangered species. Okay, endangered species. Okay, so these are the factors. Okay, so let's check once again. So first of all, topography for storage up on the upstream side, the slope should be gentle, and river channel should be wide. On the downstream side, that is hydropower generation side, the slope should be steep, and river channel should be narrow. Okay, so this is topography. Then foundation condition should be favorable, and hard rock is most favorable foundation condition. Material should be easily available, and a site for spillway, there should be a suitable site for spillway where it can discharge the surplus water. Okay, and it should not be located in earthquake zone, that is no tectonic activities should be involved in that area. And labor availability, labor should be easily available. Then dam location, it should be easily accessible, and it should be well connected with town or city, and it should be connected by roads or railway. Okay, roads or railway. And then existing infrastructure should be present, because this will minimize the project cost and risk to local population. It should not be located in highly populated area, and it should we should check the site or select the site in such a way so that in case of disaster there is less chance of loss of life. Okay, and then the final thing is environmental concern, and whenever we are going to select the site, we make sure that it doesn't disturb the local ecosystem, the plants and animals and their habitats, and the endangered species. Okay, so these are the important factors that one should consider when we are going to select the site for dam construction. Okay, okay, now let's come to our next portion, that is hydropower. Okay, first of all, what is hydropower? And hydro means water. Okay, so the hydropower is the energy that comes from moving water. Okay, now number one, water flows through the dam which pushes the turbine. Okay, and number two is naturally flowing water is diverted through turbines. Okay, in both the cases, the energy is coming from moving water. One is water flowing through the dam that pushes the turbine, and is natural flowing water. Okay, so this is hydropower, that is the energy that is coming from the moving water. Okay, and this hydropower generates electricity. But how it generates electricity, that we will see now. So you can see the figure, and we will see step by step how the hydropower is generated. Okay, so first, it is the basic electricity generation through the dam. Okay, so first, the dam, it raises the river level. Okay, and raises the river level, and as you know, the dam is constructed across the river, so it raises the river level. So you can see the dam here, it has raised the river level, and then then the reservoir is on the upstream side of the dam. On the upstream side, the reservoir stores the water. So the purpose of reservoir is to store the water. Okay, so see here, the reservoir is a storage reservoir. It is storing the water. Then penstock. Okay, so what is penstock? It's a large tube and it carries water to turbines. Okay, so see here, the penstock. This is the penstock. Okay, so this is the penstock. It is actually a large tube. Okay, large tube, and it carries the water from the reservoir, to the turbine. So you can see the turbine here, you can see the reservoir here, and it is the penstock. Okay, so the penstock is a large pipe which carries the water from the storage reservoir to the turbine. Okay, and now this is penstock, and then turbine. Okay, what is the function of turbine? It is turned by the force of moving water on its blade. Okay, so the turbine, you can see the water is coming through the penstock, and this moving water turns the blade of the turbine. And what does the turbine do? It converts the energy of the flowing water to the mechanical energy. Okay, so this is the function of the turbine. And then turbine is connected to a generator. And what is the function of the generator? Rotated by turbines to generate electricity. So the generator generates electricity, and you can see here the turbine is connected by the generator with a metal shaft. So as the turbine is rotated, the generator starts working, and it converts the mechanical energy to electrical energy. Okay, so the energy of moving water that is coming from the reservoir to the reservoir through the penstock to the turbine is converted to mechanical energy, and it is done by turbine. Okay, and then this mechanical energy is converted to electrical energy, and it is done by generator. Okay, so this is the main function of a generator. Now you can see the generator produces electricity, and then there is transmission lines. It conducts the electricity to our home. Okay, so this is the entire process of electricity generation through the dam. Okay, now we will see some videos where your concept will be clear. So this is the working principle of hydropower generation. So let's see. Let's see. So here you can see a dam, and a reservoir is there on the upstream side. Now the water is flowing from the reservoir through the penstock, that is the large diameter pipe, to the turbine. Okay, now this moving water is rotating the blades of the turbine which is located at the end of the penstock. Okay, now you can see a metal shaft here that is connected from the turbine to the generator, and this generator is rotated as the turbine is rotated. Okay, and because of the rotation of the generator, it produces electricity, and this electricity we get at our home by the transmission lines. Okay, so we will see another video. So see how the water is flowing from the, so this is dam, and water is flowing from the, you can see the water is flowing from the reservoir through the penstock. Okay, so through the penstock the water is flowing, and at the end the turbine is rotated. Okay, so because of the rotation of the turbine, you can see, because of the rotation of the turbine, the generator is rotated, and because of the function of the generator, electricity is generated, electricity is getting generated, which is carried by the transmission lines at our home. Okay, so you can see the electricity is generated and carried by the transmission line. Thus we get electricity at our home. Okay, and the surplus water is carried through here. Okay, you can see the surplus water is flowing down, okay, on the downstream side. So this is the basic electricity generation through the dam, and it is one of the most important topic, and they will ask you to draw this basic electricity generation diagram. They won't tell you to draw the generator or turbine, but this diagram you should remember. Okay, this diagram you should remember, because they will ask you to draw this diagram. Okay, this is basic electricity generation, hydroelectricity generation through dam. Okay. Now some important points that you should remember. Okay, so first of all, the highest dam in India, that is Tehri Dam in Uttarakhand. Tehri Dam in Uttarakhand, you should remember the name, and height is 260 meter, length 575 meter on the river Bhagirathi. Okay, so not height, length is required, but remember the name Tehri Dam in Uttarakhand and on the river Bhagirathi. It is the highest dam in India. And then next comes is the longest dam in India, that is Hirakud Dam in Odisha, and it is on the river Mahanadi. Okay, so name of the dam is Hirakud. Total length, main dam length, not that much required, but the name of the dam, where it is located, and on the river on which it is located. Okay, and another thing, oldest dam in India, not that much important, but just keep in mind it is Kalanai Dam in Tamil Nadu, constructed by King Kadikalan of Chola dynasty. Okay, so in UPSC or state PSC examination, they might ask you the questions, but in interview there is less chance of asking this question, but these two are very important. Okay, and Kalanai Dam is on the river Kaveri. Okay, so Tehri Dam in Uttarakhand on the river Bhagirathi. Okay, and Hirakud Dam in Odisha on the river Mahanadi. These two are very important. Now let's check another important question, that is what economic height of the dam. What is economic height of the dam? And from the name economic, you can understand it is related with the cost. Okay, and for economic design, as you know, the cost should be minimum. Okay, so economic height of a dam is that height of the dam corresponding to which cost of dam per unit storage is minimum. Okay, so cost of dam per unit storage, exactly this one you should say, cost of dam per unit storage should be minimum. Okay, so this is cost of construction of the dam, this is dam height. Okay, so there is no so not this, but cost of construction of dam per unit storage versus dam height. Okay, so here you can see this curve. Okay, so you can see this curve, that is cost of construction per unit storage by and versus the dam height. So it is the point where the cost of construction is minimums. Okay, so the height of the dam, so height of the dam, so this point belongs to the height of the dam, that is corresponding to which the cost of the construction of dam per unit storage is minimum, is called the economic height of the dam. This is very important, and many times if they ask you the question. Okay, and next one is, what is the difference between dam, barrage and weir? Okay, so the main difference is dam is used as a storage headwork. Okay, and it creates reservoir on the upstream side. As you know, it creates reservoir on the upstream side, and the reservoir stores water, and this water is used for irrigation, hydroelectricity generation, flood control, etc. Okay, so this is dam. And weir and headwork, okay, both are diversion headwork, okay. So what is the purpose of diversion headwork? It diverts the main flow of the river into a canal. Okay, so what is the difference between weir and barrage? Weir doesn't so another similarity is weir does not have any storage reservoir and barrage does not have any storage reservoir, but the difference is, in case of weir, the water is raised up to the required height and then water flows over the weir. Okay, water flows over the weir, this is important, over the weir. But in case of barrage, water level can be maintained using these gates. Okay, so the water is elevated only to few feet, it has adjustable gates installed on the top of it, and water level is maintained using these gates. Okay, so this is the main difference between weir and barrage. So now you know what is the difference between dam, weir and barrage. So you can see, so this is the dam which is used as a storage reservoir. So you can see this is the reservoir here. Okay, this is upstream side and this is downstream side of the dam. You can see the water is flowing out from here, and this is where, that is, this is where, this is dam, this is where, because water is flowing over. Okay, flowing over, and you know water is flowing over the weir. So you can see this is the weir where water is flowing over, and then here this is the water level is maintained by gates, and this is barrage. Okay, so this is the main difference between dam, weir and barrage. Okay, And now another question that they will ask you is that tell me about a dam in your area. Okay. So and if you have no dam in your area, then they will ask you tell me about a dam that you have seen, if you have seen. But if you have not seen any, then they will ask you tell me about a dam that the you have heard of. Okay, so you must have heard the name of a dam. Okay, so you must prepare this question, must prepare. Okay, so they will, because they will ask you about a dam in your area, or if you have seen any, or if you have heard of. Okay, so any three of this. Okay, so let's take a dam, name of a dam. I have taken Maitan Dam, that is in Jharkhand. Okay, so what are the points that you should consider when you are going to tell about a dam? Okay, so let's check. Name of the dam is Maitan Dam. Where it is in Jharkhand and constructed over Barakar River. Okay, so these 2 points are very important. Where it is located near the border of West Bardhaman, that is in West Bengal and Jharkhand. Okay, so in the border of West Bengal and Jharkhand, and it is an earthen dam. Type of dam is earthen dam. Okay, so one information is name of the dam Maithan in Jharkhand on the river Barakar River. In it is an earthen dam with 12 lock gates, and these are some extra information that you can remember. Okay, so one is the 4789-meter long across Barakar River, 150-foot height on the upstream face, purpose flood control, hydropower generation, supply irrigation water, and Maithon hydel station. Okay, so the information that you should remember is the name of the dam, where it is located on the river, and the type of the dam. Okay, so this is about a dam that you have seen. Okay, next is Farakka barrage. Okay, so it is Farakka barrage is of high importance because it has a high historical background and political background. Okay, so so just study this about Farakka barrage. Okay, it is important because I have faced this question. That's why I have selected this question. Okay, so Farakka barrage, and the name of the barrage is Farakka barrage in Murshidabad and Malda district of West Bengal. Okay, so Farakka barrage project and complex project comprising Farakka barrage, Jangipur barrage, feeder canal, navigation, lock, and associated structures. Okay, and it barrage comprises of 112 gates, and as you know, on the barrage the flow of water is controlled through the gates. So here 112 gates are there, 108 main gates, and 4 fish lock gates, and 11 head regulators. Okay, not that much information is required, and it diverts approximately 40,000 cubic. Okay, just remember this information because it is important from historical issue. 40,000 cubic water of discharge into the feeder canal. Now what is feeder canal, that I am going to tell in the next slide. And project construction 1961 to 1975. Okay, this is important. Okay, so these are some information regarding Farakka barrage, and it is in Murshidabad and Malda. And okay, this now see, this is the Farakka barrage. This is very important. Okay, now we will see main objective of Farakka barrage. What is the main objective of Farakka barrage? Very important, very important objective: to divert the adequate quantity of Ganges water to Bhagirathi Hooghly river system through 38.38 kilometer long feeder canal. It is historical, it has historical importance. Okay, so if you want, you can study this. Okay, and to improve the regime and navigability of Bhagirathi Hooghly river system. Okay, so this is very important, to divert the adequate quantity of water, because the water was flowing before construction of the barrage. The water was flowing to the Bangladesh, and the name of the river is Padda when the Ganges goes to Bangladesh, and and that's why there was less amount of water in this Hooghly river system. Okay, so that's why Farakka barrage was constructed, so that they to divert adequate quantity of Ganges water to Bhagirathi Hooghly river system through a feeder canal. Okay, and it is well connected because rail cum road bridges built across the river Ganga at Farakka established. As we have seen a favorable site, so it should be easily accessible and well connected to the town and cities by roads and railways. So you can see rail cum road bridges built across the river Ganga at Farakka establishes direct road and rail communication, which is important, that we have already studied. to the northeastern region of the rest of the country. Okay, and Farakka Barrage project is facilitating implementation of agreement on sharing Ganga water between India and Bangladesh. Okay, as I have said, it has high historical importance. So sharing the Ganga water between India and Bangladesh. Okay, so these are some important information regarding Farakka Barrage. Now we will study about the feeder canal that just we have read. So what is feeder canal? A feeder canal is constructed to feed two or more other canals or branch canals. Okay, so you can see the feeder canal here. So it is constructed to feed two or more other canals. Okay, so you can see Farakka barrage here. Okay, and Farakka barrage was made to divert the water from the Ganga to the Hooghly. Okay, this is the main purpose of constructing Farakka barrage. The Hooghly river became dry many times during the year because water of the Ganga wholly flowed into Bangladesh through the Padda river. As I have told, the water is being diverted to Hooghly from Farakka by a feeder canal. Okay, by a feeder canal, and a feeder canal is constructed to feed two or more other canals or branch canal. Okay, now the problem was that the level of a feeder canal is 10 meters higher than the level of the Ganga. Okay, so the level of feeder canal is 10 meters higher to the level of Ganga. So how the problem was solved? So it was necessary to raise the level of water in the Ganga by 10 meters to put the water into the feeder canal. Okay, because the level was 10-meter high, because the level was 10-meter higher, so it was necessary to raise the level of water in the Ganga by 10 meter to put the water in the feeder canal. And as we know, the purpose of the dam or barrage is what? To raise the water level. Okay, so it was 10-meter high, so it was necessary to raise the water level, and so the Farakka barrage was made to raise the water level. So what we have just studied, the function of dam, function of dam, function of dam or barrage. Okay, so this is the practical implementation. So you can see the practical implementation here. Okay, so that's why I have included this portion here. Okay, so what we have studied, everything you can see here. The purpose of the dam, purpose of the barrage, that is diversion headwork, and purpose of diversion headwork is to divert the main course of the river. And why Farakka barrage was constructed? To divert the water from the Ganges river to Hooghly. Now the purpose of the dam or barrage is to raise the water level, and here it was 10-meter high, so Farakka barrage was constructed. So the Farakka barrage was constructed so that the water from the Ganges is diverted into the Hooghly river by a feeder canal. Okay, so this is all about the feeder canal. So we have read about Farakka barrage. Now based upon your state, or you can say any of the dam. So I have included a name of some important dams state-wise. So it is Bhavani Sagar Dam in Tamil Nadu, Tungabhadra Dam in Karnataka, Rihang Dam in Uttar Pradesh, Maidhan Dam in Jharkhand, Koyna Dam in Maharashtra, Bilaspur Dam in Rajasthan, Mettur Dam in Tamil Nadu, Krishna Rajsagar Dam in Karnataka. So also study the name of the rivers. Okay, and next is Indira Sagar Dam in Madhya Pradesh, and Cheruthoni Dam in Kerala, Sardar Sarovar Dam in Gujarat, Nagarjuna Sagar Dam in Telangana, Hirakud Dam in Odisha. Hirakud Dam is the longest dam on the river Mahanadi, as we have told. Fakranangal Dam, Punjab Himachal Pradesh border, it is also very important. Tehri Dam is the highest dam, and Hirakud Dam is the longest dam. Tehri Dam in Uttarakhand on the river Bhagirathi, and Bhakrarangal Dam on the river Sulej, and Kangshabati Kumari Dam in West Bengal on the river Kangshabati, and Subansiri Lower Dam on the Assam Subansiri. Okay, so these are some state-wise important dams you can see, and so you can select any of the dam and study a little bit about the dam. Okay, Okay, so from starting, what we have studied is, first of all, what is a dam, and then the important terminologies, that is foot, hill. Okay, and then the classification of dam, that is different types of dam based on design, based on function, based on the material used, and then we have studied about the about hydropower, about hydropower, and how hydropower is generated, and then we have studied the difference between dam, weir, and barrages, and then we have studied about the economical height of the dam, economical height of the dam, and then we have studied about a name of any dam, name of a dam, a name of a dam of your favor, of your choice. Then longest dam, highest dam, longest dam, then longest dam, highest dam, etc. And then we have studied about Farakka barrage, and then we have studied about feeder canal. Okay, and we have also studied the site selection for dam construction, and also the state-wise name of the dam, name of the dam, state-wise name of the dam. Okay, so these are the things that we have studied in today's video. Okay, so let's conclude our discussion here. Okay, and in our next video we will discuss some other important questions. Okay, so thank you for watching this video, and if you find this video helpful, don't forget to share among your friends. Okay, so let's end our discussion here, and I wish you best of luck. So have a nice day and goodbye.